Now, let's look into the overall portion again. Now, the overall portion, we can look into the collision collision category. And if we look into this one, you can also see that the gap between 30 to 59,000 with more than 60,000 is a little bit much smaller compared to the gap when it's a non-fraudulent claim. And now let's test again whether the new column that we created is still statistically significant when it is compared to the fraud found. So here it says that the new feature that we created is still statistically significant, and the same thing happens for all perils too. So for collision and also for all perils, this new feature that we created is okay to use. And now that we have statistical grounds that our new feature still has relationship with the fraud found, we can dig a little bit deeper. So the main question that we had is the portion of vehicles that are priced more than 60,000 higher when it comes to fraud compared to non-fraudulent claims? So we can manually calculate all these portions. So for non-fraudulent claims in all perils, we have 3,997 different rows. And for claims, we have 452 claims, fraudulent claims. And so this 2,552 is the value for less than 30,000. And if we look into the portion, so 63% of the claims belong to less than 30,000 priced vehicles in non-fraud, and 62% for fraudulent claims. So the two portions are overall pretty similar. So it doesn't quite seem that there's a difference in portion when it comes to vehicles less than 30,000. Now let's look into the very high-end vehicles, the expensive ones. So out of 452 claims, 100 of them were related to high-priced, expensive vehicles, and the overall portion will be 23%. But if we go to the non-fraudulent claims, you can see that only 18% of overall claims are related to expensive vehicles. And if we look into the portion of average vehicles, it looks like this. So the main thing that we should be looking for is the overall pattern. So 62%, 23%, and 14% are all add up to 100% and these are all in the category of fraudulent claims. And the left side numbers all are related to non-fraudulent claims. So we want to compare whether the portions for each individual vehicle types are different when it comes to non-fraudulent and fraudulent claims. We can do the same thing for collision. If we calculate the individual numbers, you can see that for high-end vehicles, 19% are related to high-end vehicles when it comes to fraudulent claims, but for non-fraudulent claims, only 12% are related to high-end vehicles. So you can see that there are some differences in the overall portion. However, it's going to be very cumbersome and tiring and complicated if we do all of these by hand. So we need to come up with some kind of systematic way to do this and more efficiently. So one of the methods to do this is to use the pandas crosstab function. So the crosstab function, if we provide the index and the columns, then it will provide the table that looks like this. So it will be much more better if you can just look into the result right away. So we're providing the vehicle price num column and also the fraud found column. And also we're going to normalize it by the column. If we don't normalize it, we're going to get the raw data set. So these are the raw data sets, the value counts that fall into each category. But if we provide the normalize function, it's going to normalize by the column. So it's going to normalize by the column, which is the fraud found, and these three will add up to 100%, and these three will also add up to 100%. Now, by looking at this, you can easily see the difference. So for average priced vehicle, the overall portion between non-fraud and fraudulent claims is 25% and 28%. And for cheaper models, the portion is 61% and 51%. And for expensive models, it's 12% and 19%. So what we want to do is we want to understand whether these two numbers are significantly different. So if 12% and 19% is significantly different, it means that the portion of expensive cars is different when it comes to non-fraudulent and fraudulent claims. So in order to do that, we're going to use the Fisher's exact test. So this test determines whether there are non-random associations between two categorical variables. So the overall method is pretty similar to chi-square, but it works well on small sample sizes, and also it has to be a 2x2 contingency table. So we're going to only use this one column with fraud found, and then independently we're going to utilize this specific category with fraud found, and the same thing for the last category. Now, if we calculate this, we get the result like this. So the Fisher's exact test for more than 60,000, we get the p-value is smaller than 0.05, and the same thing happens for category that is less than 30,000 and category for average priced vehicles. My mistake. So for average priced vehicles, it's not statistically significant, so we cannot say that there's a difference of portion between non-fraudulent and fraudulent when it comes to this specific category. Now, if we look into the details of the code, here we are going through individual categories. If I execute this, we're going to get all the unique variables within this feature. And then we are creating a cross tab, which is the binary table, and it looks like this. And we're going to pass this to the Fisher exact test. And the result will look like this. And if we interpret this, as mentioned before, we have two levels of categories that were statistically significant. So vehicles less than 30,000. This was statistically significant, and it means that the inexpensive vehicles are underrepresented in fraudulent claims compared to their presence in non-fraudulent claims. This is because for non-fraudulent claims, we have 61.4% of them were inexpensive vehicles. But for fraudulent claims, 51.7% were inexpensive vehicles. So overall, inexpensive vehicles are underrepresented in fraudulent claims. And if this part of the category is underrepresented, there should be a category that is overrepresented, and that category would be 60,000. So this was also statistically significant. So here you can see that the class for more than 60,000 is statistically significant. And the overall pattern is that for non-fraudulent cases, 12% were inexpensive vehicles. But for fraudulent cases, 19% were expensive vehicles. So, based on these patterns, we can say that the high-priced vehicles are overrepresented in fraudulent claims compared to their presence in non-fraudulent claims. We can do the same thing for all perils too. So that was collision. And for all perils, you can see that the test result for expensive vehicles is statistically significant, but for other categories, they both are not statistically significant. Now, to interpret this, we get the same result, which is for non-fraudulent cases, we have 18.2% were expensive vehicles, and for fraudulent cases, 23.2% were expensive vehicles. So you can see that for both collision and non-perils, we have the same pattern, which is high-priced vehicles are overrepresented in fraudulent claims. So since we see this pattern in both of the categories, we can safely say that vehicles used in insurance fraud tend to be more expensive, and we can see the clear pattern in both of the coverages. And based on these findings, we always need to connect this to some kind of a business value. So based on these findings, we should provide an action plan so that the domain experts or listeners can do something about it. And for the action plan, we should start investigating expensive vehicles more. For now, based on the analysis, it's pretty clear that when it comes to expensive vehicles, the overall portion of fraudulent claim increases. So, and also it makes sense to look into those claims first, because if the vehicle price is expensive, it means that the insurance company will have to have a bigger payout. So by checking all of those one by one, the insurance company can save significant cost in the long run. And it's also pretty cost effective because we only have a few claims when it comes to expensive cars compared to other inexpensive or cheaper modeled cars. And another thing that we should mention is that the vehicle price column can have an interaction effect with other columns that we haven't explored yet. So by combining this insight with other insights, we can provide a better insight or pattern so that it's easier for the domain experts to identify fraud. But currently, we don't have much data set, so we need to accumulate more data sets. And in order to accumulate more data sets, it's crucial for the domain experts to further look into claims and find more fraudulent claims so that we can add them to our data set. So by going through all of these cycle, we can add more data set, and with more data set, we can provide more patterns, and with more patterns, the domain experts will be able to find more fraudulent claims. So this cycle will have to keep on moving. And now this will be the end of our first hypothesis. And in the next session, we're going to look into our second hypothesis. See you in the next session.